Selector.
Okay, so paper 1 core vocabulary, river landscapes in the UK. Now, as with all these videos, there is this worksheet that you can print screen, print out, or just come and grab off one of your teachers that has got all the keywords in that you can then define, and then you can watch the video, check your definitions, and anything that you got wrong you can add to. Don't be daunted by the vast number of words. This is why we're making these videos, because there's a lot of terminology that you won't use in your everyday life. So, first, river valley. The river valley is the sloping area at the side of the river channel, not to be confused with the actual river channel where the water flows. The river channel, on the other hand, is the area where the water flows. So as you can see here, we've got a steep-sided V-shaped valley, and the river channel is winding its way around what could be interlocking spurs. Hydrological cycle, or the water cycle, is basically the movement of water from the land to sea to air, and processes that take place are evaporation, when seawater is heated up and rises, it condenses, turns to clouds, and then precipitation falls on the land, ready to surface runoff back to a stream, back to the sea. Transpiration, when plants sweat out water. Drainage basin is the area drained by a river, and as you can see, there are key features of a drainage basin that you need to be aware of. Ultimately, any drop of rainfall that lands within this invisible line called the watershed will end up being drained by this river. Surface runoff. Surface runoff, nice easy term. It is when water runs over the surface of the earth. Depending on the surface, depends on the amount of surface runoff. Although this is a surface that water can run in, this ground is obviously saturated, full of water, so that also increases surface runoff, and it's going down this lovely drain. The lung profile. The Lung River Valley profile is a line that represents the journey of the river from its source in the upper course down to the middle course and eventually the lower course. As you can see, it starts off very steep gradient, gentle gradient, almost flat gradient. A cross profile, however, is a slice through the river. Here you can see 3 slices through the river in the upper, middle and lower course. Cross profile in the upper course, you can see we've got the steep river valley and the shallow river channel, whereas further downstream, the lower course, you have got a cross section that shows the wide, much flatter valley and a wider, deeper channel. Fluvial processes is anything that a river does. So fluvial is a river process, and we often talk about terms of erosion, precipitation, deposition. Erosion is the wearing away of something. In terms of water in rivers, it's a physical force that wears away the riverbed, the riverbanks, and the riverbed load, which is the material inside the river. The first one that we will look at is hydraulic action. Hydraulic action is the shear force of the water, and what it does, it traps air in cracks in the riverbed and the riverbanks, causing it to be squeezed in. When the water is removed, it expands, and eventually this constant compressing and expansion causes the river to erode away, and we can also call that cavitation. Abrasion is like the sandpaper effect. Rocks in the river channel are dragged along the bed, wearing it away. Attrition is when rocks in the river collide with each other like this and get smaller and rounder. The 2 T's can make you think of the 2 rocks banging into each other. And finally, solution. Ultimately, water is ever so slightly acidic, and that dissolves the calcium carbonate in rocks in the riverbed load, and it forms a solution where the rock is mixed with the water. Vertical erosion. This is not a type, this is a direction. Vertical means down, and this is under the force of gravity. If you're ever asked to label this on a diagram, make sure your arrow is pointing to the bottom of the river. Lateral erosion, on the other hand, is the side-to-side erosion, and again, make sure your arrows touch the side of the river channel when you're asked to label this on a diagram. Transportation is the movement of material or sediment, and there are 4 types of transportation. The first one is traction. So here you can see large rocks are rolled along the riverbed, and this often happens in times of high river discharge, such as when there's a flood. The next is siltation. So erosion, such as attrition, has made these rocks smaller, rounder, and importantly lighter, so they hop along the riverbed. Suspension, the rocks are even smaller, they now float in the river channel. And finally, solution, the material that we've just spoke about being dissolved moves as a solution within the river water. Deposition. Deposition is the dumping or dropping of material. And as you can see, there's lots of different material that can be deposited. Larger boulders such as this are deposited maybe more often because they take more energy to use, whereas as we move down into the smaller material, these are more easily carried and often deposited further downstream. Sediment is another name for the rocks or the river bed load. It is basically any material that is in the river. Fluvial landforms. So we've already said that fluvial means river, and the landforms created by rivers are called fluvial landforms, such as waterfalls, meanders, and levees. Landforms of erosion. So we know that the river erodes the landscape, and this creates a number of landforms such as waterfalls, gorges, V-shaped valleys, and interlocking spurs. Here we can see some interlocking spurs. Ultimately, it's like a zip that you've got maybe on your coat. The river has made its way around the softest, most easiest route around these large hills called spurs, and as a result we are left with these interlocking spurs, a landform of erosion. Waterfalls, one of the landforms that are commonly asked about in the exam. It's to do with alternating geology. Here are the falls of Clyde on the River Clyde in Scotland, and as you have got bands of hard rock above bands of soft rock, an undercutting process takes place. The hard rock has nothing supporting it, collapses, and the waterfalls move back. Gorges are basically steep river valleys that have been cut out by the vertical erosion. You will also have had some weathering and mass movement helping the formation of gorges, hence these steep valley sides. The next type of landforms are landforms of erosion and deposition, and these are landforms that have these two fluvial processes working at the same time. Meanders are a common one. Meanders, ultimately, on the outer curve you have erosion, a meander is a bend in a river, and on the inner curve you have deposition. Oxbow lakes are formed by this constant erosion and deposition. So as you can see here, the meander, the bend in a river, erosion is taking place there and there, creating the meander neck. Over time, this neck gets close together, and during high river discharge, such as a flood, it breaks through. Deposition then seals off the old meander, creating an oxbow lake. Landforms of deposition. So these are landforms created by the putting down of material. The landforms of deposition that we need to know about are levees and floodplains. Here you can see embankments next to the river channel. These are called levees. When the river floods, large sediment is deposited or dumped at the side of a river. However, floodplains carry on much further into the river valley, and they are large flat areas of land that the river naturally floods onto. So this is why they're liked so much by farmers, because they can farm on the fertile soils. Estuary is basically where the river flows into the sea, and it's known as where fresh water from the river meets the salt water from the sea, and the area in between where they mix is often called brackish. River valley example. They may well ask you in the exam about a river valley example. The one that we have learnt about is the River Clyde in Scotland. Flooding. Flooding is what we call it when river discharge exceeds bankful capacity. In simple terms, lots of rain goes into the river bursts its banks and floods the surrounding area. Human factors that can increase flooding are anything that's man-made. Just think about your human geography, such as land use, impermeable surfaces, deforestation and drainage systems. Physical factors, on the other hand, are natural things that contribute to flooding, such as prolonged precipitation or rainfall, the relief of the land, and the geology of the land. Flood risk is the risk of a flood happening, and we use probability. So some areas might have a flood risk of 1 in every 10 years, whereas others might be 1 in every 100 years. Precipitation is the posh word we use for anything falling from clouds, and that can be rainfall, sleet, snow and hail. Geology is the study of rocks, and ultimately we want to know whether rocks allow water to move through them or don't, as this can create flooding. Relief is the height and shape of the land. This land has got very steep relief, this very steep-sided valley, and you might recognise this as Carding Mill Valley, where some children often do river studies. Land use, what is land used for? Obviously, if you're using land on river floodplains for high-value activities such as retail parks or manufacturing or hospitals, it's going to increase the risk of a flood having negative effects. Hydrograph means water graph, and what this shows is the amount of water in a river during a period of storm. So we've got the bars which show rainfall. As you can see, the more rainfall, the more water is going to get to the river. The line shows the river discharge. This river has got deep very quick because it's got this steep rising limb. The peak discharge is here, that's the maximum depth of the river, and the time between peak rainfall and peak discharge is called the lag time. And when the river drains away, it's called a falling limb. Infiltration is the process of water entering the ground. Some rocks allow more infiltration than others. Interception, often vegetation interception, is when trees, bushes, plants intercept or stop the water from getting to the ground, also known as catching water. River discharge is the amount of water in a river, and as you can see, the river discharge here and this line has risen rapidly on this hydrograph before starting to drain away. Hard engineering are physical structures used to manage rivers and prevent flooding, and there are several different types of hard engineering. Ultimately, they can be effective, but they're very expensive and they're not very ecologically sensitive. One example is dams and reservoirs. A dam is a large concrete structure that's built across a river. A reservoir is a man-made lake that forms behind it. You can use this to manage river flooding because you can release the water as and when needed. River straightening is another strategy. Ultimately, river straightening removes the meanders, so that allows the water to travel from one point to another really quickly. For example, up here might be high value land, whereas down here might be low value land. We want the water to escape as quickly as possible. Embankments, quite simple, building artificial levees or embankments at the side of a river. And flood relief channels. A flood relief channel is an artificial river channel, usually made out of concrete, which can be opened up when the river is full to get rid of some of the excess water. Soft engineering is ecologically sensitive, and this is working with the environment and working with natural processes. One example is river restoration. River restoration is taking away all the modern things that may have interrupted natural processes and leaving it to go back to its old natural state, and hopefully the vegetation growth here will help to reduce flooding. Flood warnings, soft engineering, they tell people when a flood is due, and this is so people can react in advance. You will hear them on the news or on the radio. And floodplain zoning or zonal planning it's a large scale project, but if done correctly can reduce a lot of the impacts of flooding. Ultimately, town planners decide what they're going to put in different zones. High risk zones next to the river will be not built on at all, whereas slightly further away, which is still at risk, may be used for pastures for animals or playing fields. Further away, the high value land, which is at low risk of flooding, will be used for things like housing. Afforestation, my favourite method, is planting trees. Trees grow, they create vegetation interception, which means the river water takes a longer time to get to the river, increasing lag time, and it creates natural habitats. The only problem is trees take a long time to grow. So that was a lot of key words. However, I'm confident that using this video you can learn them all.